At the top of the page, okay, we're going to continue working with exponential growth and decay, but we're going to take a look at, in terms of the B value, what it means to double, triple, half-life, quadruple, so on and so forth. So any quantity that grows or decays by a fixed percent at regular intervals is said to possess exponential growth or decay. So down here, before we fill that in, remember growth means we're going to have a B value greater than 1. In decay, we're going to have a B value less than 1. It's still greater than 0, okay, or still positive. If your B value is a 2, what's going on in your problem? Your Y values are doing what? What do you see in your table if your B is 2? Okay? It is going to increase, right, because the B value is a positive number. It's greater than 1. But what's going to be happening with your Y values, Sarah? They're going to be doubling, okay? So when you double, you see doubling with your Y values, that means your B is 2. If you see the Y values tripling, that means your B value is 3. Half-life, your B value is 1/2 or 0.5. So let's just take a look at the first question. Question number 1 gives you the function that models, but you can do these types of questions without an exponential function. It says, suppose you have 2 mice that live in a barn. The number of mice quadruples every 3 months. So what's our B? So every 3 months. So let's look at, here's our start. When we start, we have 0 months. And then how many mice? 2. So I'm going to put the number of mice on the bottom and the number of months up top. So you can figure this out without looking at the function. So every 3 months, it's going to quadruple. So when are we going to see the next amount of mice at how many months? 3. And then how many mice will we have? 8. Because you multiply times 4. When's the next change? Because it's going to quadruple every 3 months, so 6. And then we're going to have how many mice? No? 32. Because 8 times 4. So take a minute to look at how many at 9 months, and then to finish at 12 months. How many mice are we going to have at 9? Elijah? 128. And then how many at the end of 12 months or a year? Sarah? 512. So how many mice will be in the barn? 512 mice. Okay? If you look at the question, this here, this function, this is our starting value. There's our A. Quadruple has a B value of 4. How many mice will be in the barn? Where X is your number of times, it's going to quadruple. So if you actually plugged it in, 2 times 4 to the, how many times did it quadruple over there? 4. So 4 to the 4th power, does anyone know if we just used the function rather than, what's that? Well, 4 times 4 is 16, times 4 is 64, but then 64 times 4, 256. Then if you double 256, you get 512. So you can do all these by hand. You can use the function. You have to use the function if it tells you to write the rule and then use it. But you could always do it by hand to make sure you're right. So make sense of the situation as you're using each of these function rules. So half-life. Half-life is the time period it takes for a substance undergoing decay to be cut in half. Suppose the laboratory has 37 grams, so that's your sample size. Okay, that's our starting value. We have a sample of polonium-210. Now the 210 is not a number we're going to use in our calculation. That's the name. Okay? The half-life of polonium is about 138 days. How many half-lives are we going to have in 690? So you can start with 0 days again. That's your starting. And then we have 37 grams. And keep counting out by adding what? When's our first half-life? 138 days. So you can keep adding 138. So there's the first half-life. You can find your substance amount. Okay, but keep going. Well, how did you determine that so quickly, Noah? How did you get 5 right away?
Because 690 divided by 138.
So we're looking at a total of 690 days. So if you split those into groupings of 138, so 690 divided by 138 is 5. Good. We're going to have 5 half-lives. Our B value is 1/2, and then X here is our number of half-lives. Which equals 5. So if we do it by hand, I don't have much room, we're going to cut 37 in half, and what do we get? So 18.5, there's the first half-life. The second, okay, so I'm just going to label second since we know we're going to have 5. The second, cut that in half. 9.25. Go out to the third. I'm going to start writing sideways. Cut that in half, and we get? Yep, 4.625. Go out to the fourth, and then fifth. Cut that in half. 4.625 cut in half is 2.3125. And then last, cut that in half, and we're at 1.15625 is our final answer. Okay? How much is left, or how much of the sample do we have in 690 days? We have 1.156. Good. Make sure, yes, you include your unit. To show how that relates to the function, okay, we have our starting amount A. So if you had to write the equation, every equation has a y and an x. So y equals 37 times our B value 1/2 to the x. You have to have a y and an x in it. And then when you actually do the math, what are you plugging in for x? 5. So it's going to be 37 times 1/2 to the 5th. 1/2 to the 5th is 1/32. And then 37 times 1/32 is 1.15625. So number 3, it says the half-life of carbon-14, so that's the name of our substance, is 5,700 years. We're going to start with 20 grams. How much will remain in 11,400 years? Can you see how many half-lives we're going to have? So if we have our starting amount again, so we start with 0 years. And how much of the substance? 20 grams. Go to our first half-life. Our first half-life is at how many years? Yep, 5,700. So we cut that in half and we have 10 grams. Keep going out another half-life. So from here to here we add 5,700. Add another 5,700 years, and we're at how many years for the second half-life? 11,400. So we're only looking at 2 half-lives. Cut that in half and we have 5 grams. Yep. So in this case, it didn't say you had to write the function at all. So you could do it all out by hand like we just did. How many half-lives? Well, you just shown it was 2, but you could also take the number of years total that you're looking at it and divide it by the number of years in your half-life. And we have the answer here, 5 grams. Just because it is your note page, I will give you the function that models this. Or actually, I won't. Can anyone give me the function that would model the situation? Gabe? Nope. That's not the starting amount of our substance. That's the year we're going to have our first half-life. So remember, A value is our starting amount, which was the 20 grams. So we start with 20 grams, and then our B value, we're going to take half each time. So it's times 1/2 to the x. Okay? The last one, we're just writing the functions. We're not doing any calculations. So it said you have just read a journal article about a population of fungi that doubles every 3 weeks. The beginning population was 10, so we have the function y equals 10 times, because 10 is our starting amount, 2, because the b value, again, it says we're doubling. So if we're going to double, that means our b is 2, which we can see. And then it represents the population after n weeks. Well, if we're looking at n weeks and our population doubles every 3 weeks, that's how many times it's going to double. Well, say we look at, okay, I understand what you're saying. Say we look at 12 weeks. 4. So you just divide, that's where this is coming into play. You just divide the number of weeks by the number, or the time it's going to take for one, in this case, for it to double every 3 weeks, so you divide it by 3. Here it says you have a population of 15. So it's going to be y equals 15 times, because that's our starting amount. We have the same fungi, assuming the journal article gives the correct rate of increase, write the function that represents the population. So it's the same thing. Nothing changed. It was n weeks again. So times 2 to the n over 3. In part B, it says suppose you find another article, but this time the fungi population is going to triple every 4 weeks. So it's going to change a couple of things here. We currently have 15. What's the function? That's right, it's going to triple. So that changes something. And this time it's every 4 weeks. We still have 15. Can anyone give me the equation? Sarah? Over 4. Good. B value changes, and now it's going to be over 4 weeks.